Algebra 2, Concept 2, Parent Functions and Transformations. In this part of the notes, we're going to be writing transformations of functions, and writing meaning in equation form. So if you look at example A with me, it says write a function g whose graph is a translation 3 units down of the graph f of x equals 2x plus 1. So we remember we're going to need to subtract 3 from the end of the function. That would be introduce a k value. So we're going to use g of x as our new translated function. We'll subtract 3. Then you want to simplify if you can. So our final answer will be 2x minus 2, and that will be the line that transformed the line 2x plus 1 by shifting it 3 down. B says write a function h whose graph is a translation 2 units to the left. So remember, we're going to need to do the opposite of what you would think. We're going to need to add 2 to our input. That's our x value. So our new function is g of x equals, then open up a parentheses around x, the input, and then do the math inside that parentheses. So to shift to the left, we actually need to add 2. That's our h value. And then we can leave that equation in that form, x plus 2 quantity squared. Now we're going to look at transformations of functions where they are reflections either in the x or the y axis. So A says write a function g whose graph is a reflection in the x-axis of the graph of f of x equals the absolute value of x plus 3 plus 1. So for an x-axis reflection, the entire output is made the opposite sign. So we're going to multiply by negative 1. So let's start by writing g of x. Then I'm going to multiply by negative 1. And then I set up my bracket and include that function. So the negative 1, I multiply that by the absolute value expression and by the plus 1 that's at the end. Notice that we do not multiply values into an absolute value. So they look like grouping, but they are not. It is an actual operation. So we cannot multiply things through that operation. We just have to set that multiplier out front. B says write a function h whose graph is a reflection in the y-axis. If we want to reflect across the y-axis, we are just focusing on the input, and we are going to multiply that by negative 1. We're going to make it the opposite sign. So we'll say, and I should have used h of x, but I just am in the habit of using g. So 2 times, now notice I open a parentheses around the input, and I say negative 1 times x. But when I simplify, that negative comes out front, and it's just negative 2x. So with a line, a y-axis reflection will also look like an x-axis reflection. Now let's look at vertical stretches and shrinks, or compressions. That's another name. So B says, and I'm not sure if how my lettering goes, but hopefully it matches your notes packet. Write a function h whose graph is a vertical stretch of the graph of f of x by a factor of 2. So for a vertical stretch, the entire output needs to be multiplied. So we'll say h of x equals, and I put my multiplier of 2, and then I'm a little picky with my grouping symbols, so I'm starting over there. So I have my bracket to show that I'm going to multiply that 2 by everything inside that bracket. So the absolute value, and then also the 5. So it's 2 times the absolute value of x minus 3 minus 10. Remember that when we're multiplying an absolute value expression, we just set it out front. We cannot multiply through that the absolute value expression. All right, now we're going to write a function h whose graph is a vertical compression or a shrink by a factor of 1/3. So the entire output needs to be multiplied by 1/3. So h of x will equal, and then here's my multiplier. I'm going to set up my grouping symbol, and then I take that 1/3 and I multiply it by the absolute value of x, And then 1/3 times negative 3 is negative 1. So now let's do horizontal stretches and shrinks or compressions. So we're going to write a function g whose graph is a horizontal compression of the graph of f of x, by a factor of 1/3. So f of x equals the square root of x minus 3 minus 5. So with horizontal shrinks and stretches, we multiply by the reciprocal. So if it is a shrink or a compression, we're going to multiply of 1/3 by 3. And we're just focusing on the input, which is x. So I only take that 3 times my x value. I do not multiply it through any other part of the equation. And simplified, it's the square root, the absolute value of 3x minus 3 minus 5. Now we're going to write a function g whose graph is a horizontal stretch by a factor of 2. So we're starting with f of x equals 4x plus 2. So for a horizontal stretch, we'll be multiplying by a half, just the input. So notice I open a parentheses around my x and I put the 1/2 times x. When I simplify, I do go ahead and multiply that 1/2 and that 4 together, 2x plus 2. Okay, so we're going to figure out the order, but let's do one more. It says, let the graph of g be a translation 6 units down, followed by a reflection of, in the x-axis of the graph, f of x equals the absolute value of x. So we're going to do these in order. The first thing we'll do is translate f of x 6 units down. So g of x is the absolute value of x minus 6. Now, reflection in the x-axis means we need to multiply everything by negative 1. So we get negative absolute value of x plus 6. All right, now let's work backwards and describe the transformations that we see. So on A, we have f of x equals 8x. That's our starting function. Our new function has 8x divided by 9, and then we add 5. So if I look at that divided by 9, I could think of that as a vertical shrink or compress by 1/9. I could also think of that as a horizontal stretch by 9. And then 5 units up. So either of those would give me the resulting function. On B, I start with f of x equals x squared and end up with g of x equals 2x squared minus 7. So the first thing could be a vertical stretch by 2. And then the second could be a translation 7 units down. All right, that concludes our notes on Concept 2, Parent Functions and Transformations.